right, so more properties of quadratic functions. So an equation of a quadratic function, well, what is a quadratic function? It's in the form y equals ax squared plus bx plus c. That's one of the forms. A, b, and c are constant numbers. Okay, so they're integers, rationals, irrationals, whatever. But the degree of that polynomial function is degree 2. So there can't be a cubed, or there can't be just an x term. Okay, so quadratic means degree 2. So let's look at this. That's degree 2. This is degree 3, so nope. This, what is it if we expand that out? Well, those are two binomials with x, so that would end up having an x squared term. This is 5 over x squared, so really that's 5x to the negative 2. So that's not a polynomial function, that's a rational function. So that's not. Here, this is x squared. Now notice, so that's good, but this is x to the 1/2. So we need it to be a polynomial function and then degree 2. And any exponent that's negative or rational will not be a polynomial function. You might treat it in the same way, solve it in the same way, but it's technically not a polynomial function. Okay, so the graph of every quadratic function is a curve called a parabola. The point where the parabola changes direction is called the vertex. So here it's going up and then coming down. Here it's going down and then coming up. Parabola may open down, in which the vertex will be a maximum point, or open up where it's a minimum point. Okay. Oh, sorry, put that in the wrong place. Open down, so it will be a minimum. The vertex can be found using the TI calculator 83, 84, whatever version, by selecting second. It's actually second, I like to call it second trace because that's the actual key. And then on the calculator it says calc. And selecting either the maximum or minimum. So if we take a look at our calculator, I have one up from the last lesson. Minimum is 3, maximum is 4. So 3 minimum, or 4 maximum. So you can cursor to it, or you can just enter those numbers. Okay. Axis of symmetry, we talked about in the last lesson. It divides the parabola in half because the parabola is symmetrical. So it's symmetrical about the axis of symmetry. It's a vertical line that passes through the vertex. Right, because this is called the vertex. If the vertex of a parabola is PQ, so those are the coordinates, then what's the equation of the axis of symmetry? Remember, it's always a vertical line, so x equals, and it's got to have that same x value, so x equals P. Domain of all quadratic functions, notice the arrows on the end. It's going up and to the left and up and to the right. So it's all real numbers. Range depends on whether the parabola opens up or down. If the vertex of the parabola is PQ and it opens down and the next one is up, let's do the up one, because that's that diagram. Then the range, everything is above it. So that's going to be all the values of y, where y is greater than or equal to the y value at the vertex, and q is an element of the set of reals. Then for opening down, that's where you would have something like this. So it's going to be all the y values less than or equal to q, element of the set of reals. Okay. All right, then y-intercept. So the y-intercept is the y-coordinate at the point where the graph intersects the y-axis. So these are all properties that you know. At this point, the value of the x-coordinate, remember, is always 0. Y-intercepts are always have an x value of 0. So the y-intercept can be found using the calculator by selecting second calc value. So this would be actually, as I said, trace, which is calc, value, and then typing in x equals 0. Or even faster is just to be in trace mode and enter 0. Okay, and you'll see the x equals. All right. If the equation of a quadratic function is y equals ax squared plus bx plus c, then the y-intercept, so when x is 0, that goes to 0, this goes to 0, so you're just left with c. So on this diagram here, that's c. Close brackets. X-intercept is the x-coordinate of the point or points where the graph intersects the x-axis. At these points, the value of the y-coordinate is always 0. The x-intercepts are called the zeros of the function. Okay, so that's a terminology. The zeros, anyone asks you what the zeros of a function are, it means you're finding the x-intercepts. So the x-intercepts can be found using a calculator. Again, this is trace, which is calc, and the zero feature. This is one of the methods. So for example, if I have a calculator here, okay, and if I want to find those x-intercepts of this graph, then I can go second, trace, which is calculate, 0, and then it's going to ask me for the left boundary of where I think it is. So actually, I'm going to cursor all the way. Now a fast way is I could actually punch in a value, gets me closer, and then it says, oh, okay, I've got to do this again because it took that as the value. So I'm going to go second, trace, 0. Okay, so left boundary, yeah, it's flashing to the left of where I think there's an intercept. Cursor to the right of where I think it is, and then enter on guess, and I get 0, 0. Okay, so that's one way of doing it. Another way is to go, okay, if I want the x-intercepts, that's really, instead of, in this last one I did 2200, that was for an application on the last lesson. I want when y is 0. Okay. And so now I'm really finding the point of intersection there. So second trace, intersect, and enter, 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 and it goes to the closest one. So that might be a little bit faster. Okay. So here on my intercept, so that's where y is 0. So now some examples. For each function, determine the following. Round answers to the nearest tenth. So it means we can use our calculator. So let's get out our calculator. Let's go to y equals, clear off whatever we had. Enter x squared minus 6x plus 8. We're going to change, just go to a standard window. So zoom, Z standard. Okay, and so we can see x-intercepts, we can see a y-intercept, and we're just going to, it says graph, but we're going to do a sketch of a graph. It's going to look something like that. Okay, so there's the graph. We want to then find the coordinates of the vertex. So you go second, trace, minimum, because that's the smallest, lowest value. And just cursor closer to there, enter, keep going to the right, enter, enter. So notice it's 3.000, a whole bunch of zeros, 1, negative 1. Really it's 3, okay? You can test it, so if I just go trace, 3, enter, I get negative 1. So don't put the decimal, right? You can substitute 3 in and you're going to get 1. That's just negative 1, because that's just the pixels that are, they're not small enough to give you exact. Equation of the axis of symmetry, so that's, remember, that's going to be through there. That, and then, oops, oops, and then, oh, no. And then here, that we want was 3, -1. So our vertical line is x equals 3. Domain for all parabolas is all real numbers. Okay. Range is everything greater than or equal to -1. X-intercepts, well, let's take a look. So to me, you can actually see them, right? It looks like there's an x-intercept at 2. So if you're in trace mode and you enter x equals 2 and you get y equals 0, you know it's an x-intercept. So that one I know is at 2. Maybe you can't see it. Maybe it's a decimal. So that's where you can use the second trace 0 feature. Okay, and you can cursor to the left, enter, to the right, enter, enter. So that's 4. Okay, so that's another way. And you can also graph the x-axis. So 2 and 4, don't put brackets around them. It's not a point. It's 2 separate values. Y-intercept, well, do you even need the graph? Take a look at the equation. Y-intercept is when x is 0, so that's going to be 8. Okay. All right, next one. Clear off that one. -5x squared plus 8x plus 15. Graph that. Standard window, let's see if we can see. So notice how we can't see the vertex. So I'm going to change my window. I want to go up higher for y max. So maybe I'll go 50 for y max. Still can't see it. I'm going to go 20. There we go. Okay, and then sketch that. Okay. So here, actually, going back to the last one, I could plot these. That was, what was that? 2 and 4. And this was 8. Okay, so here, coordinates of the vertex. So second trace. We're going to learn how to do this algebraically, but for right now, we're using our calculator. Left boundary, right boundary, enter. So again, bunch of 9s there. So that's really 0.8, 18.2. And you can test it out. Trace 0.8, 18.2. Okay. Equation of the axis of symmetry would be x equals 0.8. Domain is all real numbers. Range is y less than or equal to 18.2. X-intercepts. Okay. So again, doesn't look like exact values, so I'm going to do the y equals, and I'm going to graph y equals 0. And then I'm going to use intercept. So second trace intercept. Enter, enter, enter. -1.1. I think it said to the nearest tenth. Yeah. And then the other one is going to be equal distance away from the axis of symmetry. If you go trace, if you get closer, I'm going to trace onto my second function there, and get close to it. Now I'm going to go second, trace, intersect, and then enter, 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 and that's 2.7. Again, no brackets around that because it's not coordinates of a point. Y-intercept, you don't even need your calculator. It's going to be 15. Okay, so this would be 15. This is negative 1.1. This is 2.7. Okay, and so we're done with those. It says, given the following information about various quadratic functions, sketch a graph. Complete the following statement. So if the range of the function is y less than or equal to 4, then what direction does it open? So if it's y less than or equal to, it opens down. And how many x-intercepts does it have? Well, y less than or equal to 4, there's many that you could show. There's one of them. But basically, this has to be 4, and your vertex has to be somewhere with a y value of 4. Opening down, so this would have to have 2 x-intercepts. Okay? If the vertex of a quadratic function is 5, 1, so 5, 1, about there, and it passes through 2, 3 up here, okay, and this is the vertex, then it has to be opening up. Because if this is the vertex, the only way is it opens up from there or it opens down, and obviously it can't go through 2, 3 if it does. Okay, so it opens up. It has no x-intercepts. Axis of symmetry is x equals 5, the x value at the vertex. And another point that the parabola passes through, well, it's 2, 3. Well, we've already got 2, 3. So let's think about being symmetrical. So this is, what was this, 5, 1. And this is, so this is 2, 3. So think about, I'm going to switch to red. Okay. So symmetry, that means this distance is the same as this distance. So from an x value of 2 to an x value of 5, that's 3 units. So this has to be 3. So this point, 5 plus 3 is 8, with the same y values. So that's 8, 3. Okay. Next one, x-intercepts of a quadratic function, or negative 5 and positive 3. So say here and here. And the range is greater than or equal to negative 2. So remember, your vertex has to be halfway in between there. So say here, and the y value here would be negative 2. So it's going to look something like this. So the parabola opens up. Equation of the axis of symmetry is x equals, now what is it? Right? So that axis of symmetry, what is halfway between negative 5 and 3? So you can find it by taking the average of those two numbers. So that's going to be negative 2 over 2, which is negative 1. So the vertex is at negative 1, negative 2. And then quadratic function, 3x squared plus bx plus c passes through the point 1, 2 and negative 2, 26. Determine the values of b and c algebraically, because you don't know very much from that. But we do know, so for point 1, 2, that means when y is 2, x is 1. So substitute those in. Simplify that. So that would be negative 1 equals b plus c. Then for negative 2, 26, we would have 26 equals 3 times negative 2 squared plus b times negative 2 plus c. 4 times 3 is 12 minus 2b plus c. So that's 14 equals negative 2b plus c. And then you want to solve that system. So negative 1, negative 1 equals b plus c, 14 equals negative 2b plus c, and let's subtract. So b equals negative 5. So c equals 4. So then we can put it back in. So basically y equals 3x squared minus 5x plus 4.